All right, so let's look at problem solving strategies. We went over a couple things in class and we talked about that these five things should be done before saying, I can't do the problem. I don't know what to do. So let's just do a quick review from what we talked about in class. The first thing you would want to do is reread the problem. All right. Sometimes reading it once and presuming that you will actually understand the entire thing is not enough. We want to relook at the problem, really make sure you understand what's going on. Sometimes you have to identify important information and underline that important information. And we spoke in class about how sometimes important information might be called key information. We also spoke about how my favorite strategy is to draw a picture. Sometimes drawing a picture helps me realize that I am focusing that, or sometimes there's information I don't need. I didn't need that it was, whose hand it was. I just needed to know which measurement was the largest in the question. So drawing a picture sometimes helps me map out the information and then I'm able to attack it. A question you may want to consider asking is, what do I know? Sometimes it's vocabulary. We talked about the word express and what does that mean? That means to write it out. Express 3 times 10 to the second power in standard form. So it could be a vocabulary word like that. It could also be finding something that you don't know in comparison. Maybe it asks for a natural number or a composite number. You're not sure what those things are. One of my favorite strategies is the stop, think, go. And I think this is an area a lot of you need to slow down and focus on. The idea that you look at the problem and you stop and you think about it and you make sure you understand, what is it asking for? Do I have to answer in a full sentence? Do I have to explain it in sentences? Do I only have to show my work? What are the labels that it's looking for? Is it looking for centimeters? Do I need to convert? Really make sure you understand what's going on. Now, the new notes that I wanted to take right now are different strategies that we can use. So one thing that we can look at is looking for a pattern. Now, a pattern sometimes exists. A lot of you were able to figure out that multiplying by 100, it could look like you were adding 2 zeros. That's not true. The numbers were shifting, but we realized that that correlation can exist. Another strategy to look at is to use manipulatives. Now, we used it when we looked at the meter stick, and we were looking that the bumblebee in the problem was 1 centimeter long. And we had to convert it to meters, and it was 1/100th of a meter, and it actually was the decimal 1/100th. We were able to do that just with common sense without having to show. We did show all our work, of course, but we're looking to manipulate. We held that meter stick. Sometimes a manipulative is with my children at home. We're trying to build a fort. We take out all the materials we have. We might pick up a piece of wood and realize, wow, that's too heavy to use as a ceiling. We don't have, or a roof, we don't have enough, strong lumber for the sides. And you sort of manipulate the things and try it. A lot of you think about a Rubik's Cube even. That's considered a manipulative, something that you can handle and move around in your hands. Now, making a table or a chart, we know about this. We use the place value chart all the time. Not only can you use charts that are already created for you, but you can sometimes make them yourself. And we'll be doing that with a lot of the logic puzzles that we'll be tackling throughout October and November. Another strategy is make a diagram. Now, some of the way that I draw my pictures might be considered more of a diagram. There is some overlap there, but diagramming can be something like a tape diagram, but it organizes the information. There is also a guess and check. Okay, so let's continue now that I've realized the technology cut out. So we talked about making a diagram and guess and check. So guess and check sometimes is what we have to do, especially in coordination with a work backwards. So this has happened in module 1 for us a couple times in the homework and in the IXLs, and I believe it was in Azern as well. The idea that it tells you the answer, and then it says, and you multiplied by 10 to get it. What was your original number? So what number did you multiply by 10 to get 30 and 3/10? Well, we have to work backwards. And we talked about sometimes you have to do inverse operations. So those guess and checks are sometimes where we have to go. Now, something else that shows up is solving a simpler problem. So right now we're doing a lot of work with decimals. And let's say we're trying to round a whole number to the nearest 10 spot. Well, you could use that as the simpler problem for when I'm asking you to round to the nearest 10th spot. You can think about what are the processes involved? What are the rules involved? If the number in the place value is a 4, are you going to stay where you are or round up? If the digit is a 7, are you rounding up or staying where you are? So we're looking at those things, and sometimes solving a simpler problem using something you're really familiar with can apply to other things. Next is following math rules. Now, this is going to really come in handy when we start doing order of operations, which ironically has come up. I just haven't pointed it out, but there are rules in math. The idea that Nicole pointed out a really good one the other day, and I was talking about prime numbers and how a prime number is a number that is divisible only by itself in 1, and that even numbers aren't prime. My forgetting that 2 is a prime number, and it is the only even number that is prime. So I love that she pointed that out, but that is a math rule, because if it's an even number, it's always divisible by 2. So math rules are important. That helps, that what the multiplication sign means to multiply, and what is multiplication? It's repeated addition. Those ideas are the math rules that make math such a beautiful science. In fact, the Greeks refer to it as the perfect science, the primary, the one you need to master first. Pretty cool. So another strategy we can use is to use math formulas for area, perimeter. There's also different for volume. When you get into physics, there's going to be a lot of formulas. And sometimes that formula is something that we memorize, and that's what's going to help solve certain problems. Logical reasoning is something very interesting. We will be doing a lot of logic puzzles throughout this year because I really love them. I think it's a great way for the brain to understand consequence, right? So if it's raining and I go outside without a jacket, then I will get wet. If it's raining and I go outside with an umbrella and I remember to open my umbrella, I should stay drier. There's consequences. If you don't do your homework and your Zern and your IXL, then you didn't get enough practice, and you probably won't understand the concept unless you had prior knowledge and you learned it before. But logic is also done in the math we're doing. Okay, so if you multiply by 10, the value should get larger. If you divide by 10, the value gets smaller, it decreases. So those are different things that are logical reasoning. Make an organized list sometimes can go with, a loose chart, but typically a chart involves like lines and grids. But an organized list, you see me do it often. It's one of that and drawing a picture. I really enjoy doing it. It's sort of where I'm putting down the stuff that I know. Organizing my thoughts so I can see how large Jerry's hand is and how large Susie's hand is, and I can sort of map that out and see it. Now, there are other possibilities, of course, but typically they're going to fall into this realm. So these are the math problem solving strategies. I believe in thinking about how you solve a problem is very important. It can make you a better problem solver. And problem solvers are the ideal in math, because in the future, if I am not sure what 7 times 8 is, in life you have calculators. But only a problem solver would know, when am I supposed to multiply them? When should I divide them? And so we want to focus on being problem solvers and paying attention to why we do the things we do in solving math problems, and in understanding the consequences of those actions and why the numbers are doing what they're doing. So hopefully you enjoyed this, as we'll be working on these skills. I hope to expose you to all these strategies by the end of November in the various packets that we're doing for fun and enrichment. Enjoy!